Okay, so this is a pedigree that's typical of the sort of pedigrees you're likely to get in the Unit 4 biology exam. And when a lot of people see a pedigree like this, they try to solve it all in one go. They try and just look at the pedigree and somehow see in it what the mode of inheritance is likely to be, whether it's X-linked dominant, X-linked recessive, autosomal dominant, autosomal recessive, by, I guess, picking up patterns in there. But there's a better way of doing it. It takes us a little bit longer, but it guarantees that we'll get to the right answer. And that's what I want to explain to you in this little screencast. The way we're going to do this is we're going to take each one of these modes of inheritance and use it as a sort of hypothesis. So let's take the first one. We'll do them one by one. We're going to assume that this pedigree is showing a trait that's inherited as an X-linked dominant trait. That is, the locus of this gene is on the X chromosome. If that's the case, then a man who has this dominant trait must have the allele for the dominant trait on his only X chromosome. His other sex chromosomes are Y chromosome, of course. Now, he marries a woman who will, of course, have two X chromosomes, because that's what makes her a woman. And because she doesn't have this dominant trait, whereas we don't know if it's dominant yet, of course, but that's our hypothesis, then her genotype would have to be homozygous for the allele for the recessive trait. Now, they have a daughter who, of course, has two X chromosomes. She'll inherit the big A from her dad and a little a from her mum. And so it's entirely logical that her genotype would be heterozygous and she would have the dominant phenotype because she has that big A. Now, she marries a man who has only one X chromosome, and he obviously has the recessive allele on that chromosome. They have a daughter, and she can inherit a little a from both parents. That's fine. They've both got, the father has to give her a little a. Mum has half a chance of giving her a little a. She marries a man who has a little a. The brother, of course, can inherit a little a from mum. And of course he gets a Y from dad. And this is where we run into a problem with the first of these hypotheses, because this couple here now have a son who only has one X chromosome. He gets his Y chromosome from dad here, but on his X chromosome he must have a big A, because otherwise he wouldn't have the trait that we're talking about. He wouldn't have this dominant phenotype. He wouldn't be shaded in, and yet he clearly is, and yet his mother couldn't have possibly given him that big A allele. So what that shows is that this can't possibly be an X-linked dominant trait. We can rule that one out as a possibility, and that takes us to our second hypothesis, and that is that this is inherited as an X-linked recessive trait. Now, if that's the case, then this man here would have the genotype little ay. He would have to have the allele for the recessive trait in order to have the recessive trait. His wife, in order to have the dominant trait, must have a big A. We don't know what her other allele is. Well, in fact, we can work it out very quickly, because they have a daughter here who, in order to have the recessive trait, would have to be homozygous, which means that one of her little a's must have come from her mum. The other one, of course, came from dad. Okay, now this couple here this lady here marries a man whose genotype must be big AY. That's fine, otherwise he wouldn't be expressing that in his phenotype. And they have a daughter whose genotype is big A, and it must be big A little a, because mum's only got little a's to give. She marries a man who's big AY, just like her dad. And the brother, of course, is it possible for him to get a big A? Well, here's where we run into a problem. In order to not be shaded in, he would have to have a big A, wouldn't he? But his mum has only got little a's. His dad's got a big A, but his dad gives him his Y chromosome. That's what makes him a boy. So the X chromosome with the dominant allele, because he doesn't have this, if we're assuming this is a recessive trait, he doesn't have it, so he must have the big A, but his mum hasn't got a big A to give him. So that proves that it can't be an X-linked recessive trait, and we can rule that out as a possibility as well. So that leaves Two down, two to go. So the next hypothesis that we're going to take is an autosomal dominant. If it's an autosomal dominant trait, that means that the locus for the gene is on one of the 22 autosomes and not on the X chromosome. In that case, anyone who has the trait must have at least one dominant allele, one allele for the dominant trait. Anyone who doesn't have the trait has to be homozygous for the recessive trait. Okay, now this couple here has a daughter who has the genotype big A something. Of course, that something must be a little a because that's all her mum can give her. Let's check out the others here. This is this couple's son. Of course, it's possible for them to get for him to have a little a as long as dad is big A little a, but that works out fine. And the son here, if it's possible because gender's got nothing to do with it, if it's possible for the daughter to be big A little a, it's obviously possible for this son to be big A little a too. Now this guy here, and we could work through this pedigree here, but I'm just going to work down this family tree here. This guy here, who's little a, marries a woman who of course must be little a as well because she has the recessive trait. That's only possible if you're homozygous. And they have a daughter who's little a, that's understandable, but here's where we run into a problem with this hypothesis, because in order to have this dominant phenotype, you would have to have at least one big A. And yet this guy can't get a big A from either of his parents because they don't have one. They're both homozygous. So again, that shows that this doesn't work and it can't be an autosomal dominant trait either. Which brings us to our last hypothesis, that it's an autosomal recessive trait. So let's work our way through this one, shall we? If it's autosomal recessive, that means that anyone who has the trait must be homozygous for it. Okay. Now that's possible, of course, if this man marries a woman who's big A, little a. That's the only way these two here could get a little a from both parents. But this girl here, of course, could get a big A from her mum and a little a from her dad. Must have got a little a because that's all dad's got to give. They each marry someone who has a big A something. We don't know what that something is because these people are marrying into the family. We don't know their parents or anything like that. Now, if we take this couple here, they have a daughter who gets a big A from dad and a little a from mum. Same with the brother, would have to be the same. She marries a man who has big A something. So, of course, with that combination, it's possible, of course, for them to end up with kids who are little a, as long as that man is big A, little a, which is quite believable. Again, he's marrying into the family. Possible for one, it must be possible for the other. And of course, they both have a big A, so it's quite possible for them to be either big A. In fact, they could even be big A, big A. We don't really know, but either way, this is quite explainable. If we look at this couple here, again, the same situation. It's possible for them to have a baby who's little a, as long as this woman is heterozygous, and it's also possible for them to have a baby who has a big A. It's quite believable. And here, of course, it's possible for this couple to have babies who have a big A something. It could be, for example, that this girl here is big A, or she could be big A, little a. Either way, she can easily give a big A to both of her kids. They're, of course, in this case, going to get a little a from dad, but nevertheless, it's quite explicable, it's quite explainable, quite believable that they all have the dominant allele. And so it's possible, we've shown, that this pedigree could be an autosomal recessive trait, and since it's not possible for it to be any of the other three, we've proven that it's an autosomal recessive trait.